Everyone, welcome to day 4 of my honest interview preparation. Yesterday we understood the two-pointer pattern conceptually. Today we'll use the same pattern to solve a very common interview problem. Remove duplicates from a sorted array. This problem looks simple, but it tests how clearly you understand and apply a pattern. So let's begin. We are given a sorted array and we need to remove duplicates in place and return the count of unique elements. Notice the keyword here, sorted. That's not accidental. Also, by removing duplicates, we do not want to shorten the size of array. We will just accumulate the unique elements towards the beginning of the array. Because the array is sorted, all duplicate elements are next to each other. This single observation allows us to solve the problem without using extra space. We will use two pointers. The fast pointer scans the array and the slow pointer keeps track of the last unique element we have seen. The slow pointer only moves when we find a new unique value. Let's see this visually. Initially, slow pointer is at index 0 and fast pointer is at index 1. We will compare the values at slow and fast pointer. As the values are equal, we will move fast pointer by 1 and the slow pointer will remain at index 0. Now we will again compare the values at slow and fast pointer. The values are now different. So we will increase slow pointer by 1 and replace the value at new slow pointer with the fast pointer. So this will become 2. Now the fast pointer will again move by 1 and slow pointer will remain at 2. We will again compare the values at the new fast pointer and the slow pointer. The values are same. So the fast pointer will get incremented by 1. Now when we compare the values at slow and the new fast pointer, the values are different. So we will increase the slow pointer by 1 and replace the value at the new slow pointer with that of the fast pointer. So now this will become 3 and this will remain as is. So this will be a new array. So the logic is straightforward. We start slow at index 0. The fast pointer goes from left to right. Every time we find a new value, we move slow forward and place that value there. We traverse the array once, so the time complexity is O of n. We don't use any extra data structure, so the space complexity is O of 1. Always remember, two-pointer works here because the array is sorted. If the array was not sorted, this approach would not work. Saying this out loud in interviews shows clarity of thought. Let's translate this logic into code. In case of an empty array, we return 0. We initialize slow to 0 and the loop starts fast from index 1. Whenever we see a new value, we increment slow by 1 and override its position with the value at fast pointer. At the end, the number of unique elements is slow plus 1. Let's run this code. Now we see 3 is returned from the function as these are the number of unique elements in the array and this is the updated array. The initial few elements are the unique elements and it does not matter what comes after the unique elements as we are only grouping the unique elements towards the beginning of the array. That's it for day 4. Today we applied the two-pointer pattern to a real interview problem. Tomorrow we'll continue building on this pattern with another variation. See you in the next one.